Hello folks, so today we'll continue the previous discussion we had about the hexagonal architecture, and today we'll look at a small specific example in code of what we were discussing last time. So here I have a few things. First, let's see, I already have set up a folder structure the way I was describing. So here we have adapters, application, domain. By the way, maybe just to remind, right, so we finished last time here talking about that it's useful to separate the application in 3 layers, or like the whole system in adapters, which know about the outside world, application, which holds the most of the business logic, and domain, which is pure classes and mostly is kind of the business language for the application. And then also that adapters also can be either drivers, those that trigger something in the application, or they can be driven and then they're used by application to accomplish stuff like databases. So now with this out of the way, again, let's switch back to the code. Here on the left, you can see that I have the same structure, adapter, application, domain. And you could see that in domain, for example, I would have classes like a recipe or a user. They're not complete yet at this point, but you could already see that they're extremely small. They're very kind of shallow, like just a data class, just some types. While if instead we will look into the application folder, that's where you will see kind of more specific classes, like for example recipe book, which is like the interface for our application. This will be the recipe book application, which knows how to get into recipes, maybe create recipes, this kind of stuff. And then there will be an implementation, and this is what we're actually going to talk about today, this repo. But before we look more into it, there's also adapters folder, and you can see here that I already have 2 subfolders. So for now I haven't separated adapters in driving and driven. Probably for this project I will just leave them here. It will not, probably there will be just not enough adapters to separate those. But you can see that I already separated the HTTP, so this will handle the API stuff, versus persistence, which will in future handle database. For example, for now I have an in-memory repo, and that's what we actually are going to use today to check more how it looks like in the code. Let's actually switch to GitHub. And something different that I've done this time is I prepared a pull request which holds all the meaningful changes together. And so let's actually try to walk through this pull request and along the way see how things are done in the hexagonal way. So in this case, we have a pull request which is going to add a recipe repository interface and also an recipe repository in-memory implementation. The description here is quite shallow, but again, the project is just starting and there is really not much context at this point. Ideally, for good PRs, you probably would prefer a bit more meaty descriptions. You can see we have 3 files that we are adding here. You can see them on the left, and the one we can start with is the recipe repo.py. And you can see that this class, it inherits from a protocol. So this will be an interface. And I have here a small doc telling that this is an interface for recipe repository. And for now, again, not much to discuss here. So I've added just some nodes, partially for myself. Maybe in future I'll change this documentation. What's quite important to notice is, well, first of all, this defines, as any good interface, only signatures. It doesn't define any implementations. And by the way, yes, in Python, the program, like the interpreter, will not enforce these kind of things. So in reality, this class, this interface is created only for the developers themselves to communicate. And we will see how this is used in a minute. And this interface for now defines 2 methods, one to get a recipe and one to create a recipe. And actually there is something interesting here that we'll see. I think I spotted a bug, which is awesome to have, that's why you do a code reviews. In addition to this interface, we are also going to have an implementation, which is here above, recipe, repo, in-memory implementation. And then we're going to have some tests down here below. Now, again, this being a protocol means that this class, this implementation doesn't inherit, like a child class. It doesn't inherit from it. This is like what's called composition versus inheritance, where you ideally, like in other languages, there is a special keyword, something like implements, that still would check that these things are implemented here, but they would also allow to implement many different interfaces, while with inheritance, there is an absolutely best practice to have only a single inheritance. Like as soon as you try to do multi-inheritance, you get into the opportunity for many, many troubles, which are very hard to debug. Now, this implementation, this is in-memory implementation of a recipe repo protocol. So that's kind of this my current attempt to tell myself and anyone else in future that this is implementing a recipe. Maybe in future I'll find even more strict specific wording to say, hey, this is an implementation. But I think the main enforcement I will be going to do is with tests. And that is a very practical way to do it. But for now, let's look at this class. It also implements two methods, the get and the create. And you could see that both are using an internal dictionary. That's why this is an in-memory implementation. Both are using, these methods are using a dictionary to either put something in here or to get it from here. And the dictionary is very simple, recipe ID and recipe. By the way, you see that here I'm not using string, for example. So actually recipe ID, let's check it in the code. Recipe ID comes from a domain class. So that's where we're using domains. And again, this recipe lives in adapters. You can see, right? It's in adapters, which means it is allowed to actually look deeper into the structure of the application. But going back here, if we check in the domain, the recipe class also, like the file which holds this class, also declares few types. One of them being recipe ID and another would be an ingredient. And you can see both are string, which means that here I could substitute this and I could just write dictionary of a type string recipe. But when you read it like this, when you read it like dictionary of type recipe ID recipe, you understand better what is the key. You now don't need alternative. The only way otherwise, if it would be a string, the only way to understand what piece of data goes here would be for you to scroll through the code. And you can imagine maybe this is a long file. Yes, right now it's very short, 30 lines, but it could be hundreds of lines, in future. The only way would be to locate this method somewhere, create, and then find this line in this method, and then you would see that this ID, and then you actually have to understand what this ID is. Like you have to see, if there would be no recipe ID, this ID would be again just a string, and then you would not even be sure. So then here I would have to say that it's repo recipe.id equals recipe, which actually might be a good thing to do anyway, to have it a bit more verbose. So let's suggest as the comment for myself here, recipe ID. Start the review. It still will be a bit more self-explanatory, but the good thing about this way of doing more precise types is that even if this is a string, now you know this is something unique. Also in future, if this recipe ID will become something different, it will be easier to change it, because in most places it will already be this ID. And as long as it, for example, has a method to hash itself, to be equals, many different places will be just using it as it was before. So anyway, so this is an in-memory implementation. What is it doing? Very simple. I mean, it creates a new recipe. It generates a new UUID. as an ID, and it by the way, it automatically can make it a string here with a str function. While UUID would definitely be a bit better to store in the database than a string, for this small implementation, I would say it doesn't matter, and then having a string is way more universal. And premature optimization is not a good idea, while if it's a string, I can have just whatever ID. If tomorrow I decide to have different IDs, the data model will have no issues with that because it's a string. And then there is a get method, the recipe ID. By the way, notice that it also has a user, right? So when I want to get a recipe, I don't only have an ID. Each recipe is owned by some user, and so I have to provide the user ID to the app. And then it will just try to get from the dictionary, it'll try to get the recipe. If there will be none, it will be returned none. And also, and that's why instead of this, I could use a different method. In dictionary, there is .get method, where I can provide defaults. So I could say, wrapper.get. But here below, I'm also returning none. A recipe.userid doesn't equal. So if it's owned by a different user, and of course, by the way, here you can see that now this doesn't look as if the keys are non-unique, and that's actually maybe, oh, there is nothing here. Okay, yeah, this requires keys to be unique across all user space, not for a single user. But for now, again, this is a simple way to double check that it's owned by a proper user and return recipe. By the way, you can see that this chunk of the app does not do any authorization. It doesn't check that this user has kind of the rights to claim this, the resources of that it has to claim. It doesn't do authentication with passwords. At this point of the app, we already believe that this user was authenticated and authorized for these actions. Otherwise, this is the chunk that has to live there in the API handles. So, okay, this is an implementation, pretty straightforward. Maybe let's for now hide the comments so that we can read it back. Very simple implementation, quite straightforward interface. And then there is a number of tests here. I declare a few Python PyTest fixtures so that there are some default data. And then I do some tests. Again, I prefer them to even explicitly say given when then, although this line probably should not exist. So let's suggest to remove the line. And I check a few things here. I have a test to check that the recipe fills the data. And then I have a check to do that. If I create a recipe, I then can get it back. So it is gettable. I also check that the wrong user will return none, which is important. That the non-existing recipe will return none. And then that the same recipe, kind of the same ingredients can be created, and two recipes will get different IDs and will then afterwards be different recipes. You could also see here that if it's like this recipe, because it's a data class, right? Because the recipe itself is a data class, it's comparable by default with all fields being equal, and that's what allows me to write very simple this assertion and very simple this assertion. And they're not going to compare references, they're actually going to compare values of these structures to decide on equality. Something that I think I spotted iffy is that when I wrote this interface first, you could see that this doesn't have the user. This definition has only ID, and actually it's a string. And so this is a big bug. And this is part where I either have to tune something like NumPy or something, but I would like NumPy to enforce this for me, because right now, maybe I should try to check if recipe, I should maybe do a test where it tests if I can assign one variable to another, because here this definitely should be recipe ID, right? And it also should accept user ID. So this is definitely missing here. This was like an old, I actually first done this very simple interface definition. Later when writing tests, and this is why writing tests first is really amazing, I discovered that it doesn't make sense without the user ID, but I forgot to change that interface. And also here I'll make somewhere comment, a test to check if let's copy this. No, cancel. If an instance, a test is missing, check if an instance of a class can be assigned to a recipe repo variable. Let's rephrase it, variable of type recipe repo. Actually using direct language instead of swapping this, while it will be a bit longer, is found to be way more verbose, but also way more understandable, less confusion. So that's why I get a habit myself to write it this way. So at this point, this is there. Finish the review, request changes. Oh, okay, well, I'm myself, so I cannot actually request changes from myself, but this is here now. And this will conclude our current example. So again, to check, you see here, what is also important here, the interface is defined in the application folder. This allows both application and adapters to access it. With adapters, you see how this adapter implements this interface. We can also check, I think I have it already, where am I using this interface? And this is in the recipe book. And for now, this is like a kind of almost non-existent implementation, but what you can see is then when we create a recipe book, which will hold all the logic about creating and getting recipes for the HTTP, for the API. When we create it, we in the initializer, we provide recipe repo, not the in-memory implementation. Because both, that will be very tight coupling, but also because that implementation lives in adapters, and this is application. Application is not allowed to go to adapters. We get the recipe repo here. It's the job of someone else to find the proper implementation and provide us with it. And then we just call self.repo.create. Again, probably here there will be a bit more logic at this point. You can see also user is not passed here, so this class I will continue to work on. But this is just an example how it will be used, and then also maybe to see how it is created. So where this recipe repo comes from, we can see here that when we create the recipe resource, which is part of the HTTP, we already need the recipe book, like the whole book provided. So now if we travel to the very top of our app.py, and then, so this one will be it. So when we are going to create the whole application, we need recipe book to be provided. And here recipe book is like that whole thing. And so it will be here in this method, which doesn't exist yet. Because you see, it lacks. If I would run this right now, I haven't run it in a bit, it would complain that there are no available things, but you can imagine that here we will create a book, so there will be like book equals recipe book, and it will need an implementation of this interface of this receipt repo. And so here we would first have to do something like repo equals, and here we can say, because this is an analog of the adapter, like this starting, it is like a top level app or you can also think a binding app. This is where we could say that, hey, in memory, well, I'm not going to import it right now, but in memory implementation will be the repo, and with this repo will be provided here, and then this book will be provided here, and this will be the place which binds the things and decides what to do. Also in tests, there will be a different place which will do it, and there you can imagine that I will maybe provide a different implementation, like mock implementation for tests. But that's just an example how all of this is binded. In other languages, many times it's done by the thing called dependency injector, something that kind of automatically goes and finds these things, implementations of interfaces, and then substitutes them. There are these kind of things for Python. I would say I'll still have to see if I could do this more manual injection or if I use a dependency injector. But this will be a bit outside for now. This was an introduction with a code to the hexagonal architecture, and I'm definitely going to implement those comments that I found, like the issues with the PR. Again, this is why it's nice, even if you develop yourself, to do the PRs, to do the self-review of the code, kind of to go with it like you would explain it to someone else, because you can spot issues, how I've spotted issues in my code, and that is perfectly normal, and it's really important to do so. So thanks for being with me, and have a great day. Ciao.